Hi everyone, we are back and we are going to get into our third lecture in this mechanical engineering module and section of the course. And our third section is going to be dedicated to concepts of dynamics and vibrations. So you're all experts now in statics. You know that this is equal to be zero. Some of the forces, some of the moments be equal to zero. But now we are going to do something drastic. Now stay with me here. Not equal to zero. So now we're going to be looking at objects that are indeed moving, that are undergoing some acceleration. So not constant velocity, acceleration. So the sum of the moments now will be equal to some acceleration in a particular direction. We're going to be looking at acceleration, translation, and rotation. Acceleration is kind of a given, but anyways, we can move past that. So how are we going to determine, or what are the fundamentals when we're thinking about how we think about dynamics? You'll learn about this a lot more, obviously, actually, probably hopefully at the same time in your physics course, but we are going to be analyzing the displacement of a system or a body. We are going to be kind of breaking down into translational displacement versus rotation. So if I have an XY axis, translational displacement is a body that is basically translating in an XYZ coordinate system. Rotation is basically an angular displacement around some axis. So we want to distinguish between these two modes of dynamics, and we're going to come across those obviously a lot. So we want to analyze the displacement as a function of time. So the position of the body as a function of time, x of t. We can define the velocity as the derivative of the displacement as a function of time. So obviously the position is going to be a meter. The velocity will be a meter per second, and then acceleration will be meter per second squared. So those are going to be how, again, acceleration is the derivative of velocity, or the second derivative of our displacement. So this is all translational motion, and it will be the sum of the forces will be equal to ma. Additionally, we will make this really critical basically definition that the sum of the moments about the center of mass must be zero for any body undergoing translation. But so that is really critical. So for undergoing translation, the sum of the moments at the center of mass, the location of the center of mass of a body, we're going to give you where the center of mass is. In statics, you're going to actually calculate for the center of mass of any arbitrary body or any arbitrary geometry as well. But we'll be giving that to you. But some of the moments about the center of mass must be equal to zero. Additionally, you can also basically just take the sum of the moments around any point must be equal to the acceleration here that we see. So you can pick any point. If this is the center of mass G, I can do the sum of the moments at any arbitrary point here must be equal, the sum of those moments must be equal to the sum of essentially that acceleration here. So that is all about translational displacement or translational motion. Next video, we're going to get into our critical definitions for the rotational motion. So we'll see you then.